In the previous videos, we defined instantaneous and average speed, instantaneous and average velocity. Based on velocity, we further can classify the motion into two types: uniform motion and non-uniform motion. Motion is said to be uniform only if it covers equal displacements in equal intervals of time. A motion is said to be non-uniform if it covers unequal distances, or I should not say distance, I will come back to this, unequal displacements in equal intervals of time. Why not unequal displacements in unequal intervals of time? Because unequal displacements in unequal intervals of time may still represent uniform velocity. For example, an object covers in the first second 4 meters. In the next 3 seconds 12 meters. While this is unequal displacements in unequal intervals of time, this may still not represent non-uniform velocity, because velocity in this first second is 4 meter per 1 second, which is 4 meter per second. In this case is 12 meter by 3 seconds is equal to 4 meter per second, which will still result in the same uniform velocity. So whenever we define, we need to be careful about defining non-uniform velocity or non-uniform motion. That means an object covers unequal displacements in equal intervals of time is called non-uniform velocity. I'll give you one example. Like I just think of introducing a little bit higher concept. In uniform motion, instantaneous velocity and average velocity are the same. In uniform motion, if you find instantaneous velocity at any instant and you find the average velocity for the entire motion, these two will be equal. Let me just give you an example. This is a road and you are standing here, you are having a robotic toy and that is here, and you place it when time t0 is equal to 0. That means you have a stop clock, you are turning on the stop clock. At that time the object is with you, so the distance from you or the displacement, the position is 0 here, so S0 is 0. It is running. When time is t1, its position S1. When time is t2, its position is S2. When time is t3, position is S3. Let us assume these times: 1 second, 2 second and 3 second. And the position 4 meter, and it moves further 4 meter. So the position is 8 meter and this position is 12 meter. I am not saying displacement, the position. It's a 4 meter mark, 8 meter mark and 12 meter mark. Let's find out what is the average velocity. Average velocity is the total displacement by total time taken. So V average is equal to total displacement. What is the final position of the object? 12 meters. What is the initial position of the object from you? 0 meter. So V average is S final, which is S3 minus initial position 0 by final time is T3, initial time is T0. This change in position, this change is referred by delta, which is the fourth Greek alphabet. So delta S means change in position, by delta T is change in time. So S3 is 12, S0 is 0. So 12 minus 0 here divided by 3 minus 0 seconds. 12 minus 0, 12 meter. 3 minus 0, 3 seconds, which is 4 meter per second. This is the average velocity for the entire journey. Let's look at the instantaneous velocity in the second. What is the second? This 0 to 1 second is over. Once 1 second is over, this duration is the second. So what is instantaneous velocity of the object in the second? V instantaneous is equal to this instant, the second second. In the second second, object moved from S1 to S2. So the change in position of the object is S2 minus S1 by the duration. The time interval is T2 minus T1. So what is this S2 minus S1? Change in position. Because it is a small change in position for the entire motion, the small change in position is referred by the small Greek alphabet delta, which is d. S by dt. This ds is often delta s can be written as ds by dt. What is ds? 8 minus 4, which is 4 meter, by what is dt? 2 minus 2 seconds minus 1 second, which is 1 second, which is again 4 meter per second. So instantaneous velocity in the second second or third second or the first second or any second or in the 4th meter or 8th meter. So in an uniform motion, instantaneous velocity and average velocity are the same. What I have drawn on the board is an example of a non-uniform motion. As in the previous case, this is a straight road. A robotic toy just runs on the road and you have just marked the positions of the robotic toy after 1 second. So when you just turn on the stop clock, it is at when the time is 0th second, it is at its position is 0 meter. That means it is with you, and after 1 second it is at 5 meter from you. After 2 seconds it is at 20 meter position from you. After 3 seconds it is at 45 meter position from you. You clearly could see it covers unequal displacements in the same 1 second, that is equal intervals of time. But let's analyze this motion. First, what is the first time interval? Small time interval dt1 is t1 minus t0, t1 minus t0, 1 minus 0. So dt1 is 1 second. What about the next time interval? dt2 is t2 minus t1. So t2 minus t1, which is 2 minus 1 second. So it is dt2 is 1 second. What is the next time interval? dt3 is equal to t3 minus t2, t3 minus t2, which is 3 minus 2, which is again 1 second. Let's look at the change in positions. In the first second, the first change in position ds1 is s1 minus s0, which is 5 meters. In the next 1 second, next change in position is 20 minus that is S2 minus S1, 20 minus 5 meters, which is 15 meters. In the next 1 second, the change in position ds3 is equal to 45, S3 minus S2, 45 meters minus 20 meters is 25 meters. Now, what is the velocity in the first second? Instantaneous velocity in the first second. V1 is ds1 by dt1, 5 meters by 1 second, which is 5 meter per second. What is V2? Instantaneous, second instantaneous velocity or instantaneous velocity in the second second. So ds2 by dt2, which is 15 meters by 1 second, is 15 meter per second. And what about the next second instantaneous velocity? That means instantaneous velocity in the third second. ds3 by dt3, which is 25 meters by 1 second, which is 25 meter per second. You see, the velocity keeps on changing. It keeps on increasing. In the first second, velocity was 5 meter per second. In the second second, it is 15 meter per second. In the third second, it is 25 meter per second. So this kind of object goes with different velocities at different instants of time is called non-uniform motion. So, but there is a beauty in this. In non-uniform motion, it is not necessarily that the velocity should change with constant value, but here you look at what is the first instantaneous velocity, 5 meter per second. Next instantaneous velocity, 15 meter per second. What is the change in velocity in just 1 second? It is 15 meter per second minus 5 meter per second, which is 10 meter per second. What is change in velocity between the second and the third second? 25 meter per second minus 15 meter per second. So the change in velocity 2 is again 10 meter per second. This seems that every 1 second the velocity appears to change by 10 meter per second. This way of non-uniform motion is called uniformly accelerated motion. If the change in velocity for every 1 second is constant, then the motion is said to be non-uniform motion but uniformly accelerated motion. Discussion has become slightly lengthier and hence a slightly longer video. It's better to summarize things. Two types of motion we have just classified: uniform motion, non-uniform motion. If object covers equal displacements in equal intervals of time, then that is uniform motion. If object covers unequal displacements in equal intervals of time, is called non-uniform motion. In uniform motion, instantaneous velocity is equal to average velocity. That means velocity at any instant is equal to the overall velocity, average velocity. But in non-uniform motion, instantaneous velocity is not equal to average velocity for the entire motion. The instantaneous velocity keeps on changing. So here velocity is changing. There are two cases. Velocity change is not constant. Velocity change for every second is constant, or velocity change is not a constant, because non-uniform motion means covering unequal displacements in equal intervals of time. That means that the velocity keeps on changing. If the change in velocity is constant for every 1 second, then that is called uniformly accelerated motion. Uniformly accelerated motion. If the change in velocity is not constant for every 1 second, then that is called non-uniformly accelerated motion. So non-uniform motion can further be classified into two types: uniform acceleration, non-uniform acceleration. Uniform acceleration means change in velocity for every second is constant, so the change in velocity will not follow any trend, it just keeps on changing.